All right, welcome everyone. We're looking at just graphing this chapter. A lot was graphing quadratic functions is what we're looking at. If you know what quadratics means, that's fine. Don't worry about it. We're going to get to there in just a little bit with some vocabulary. But to look at graphing quadratic functions, we're going to first start out by looking at just how we normally study graphing stuff. We study graphing by tables. So we've got our x and y table here. So y equals x squared is our first quadratic. And I'm pretty sure we've graphed this before somewhere along the way in algebra so far. But just as a reminder, so we have y equals -3 squared. So you're plugging in that x value for x. And -3 squared, so -3 times -3 is a positive 9. So now we look at y equals -2 squared. So that would be -2 times -2, which is a positive 4. Y equals -1 squared, which is a positive 1. Y equals 0 squared, which is 0. And then keep going, y equals 1 squared is 1. Y equals 2 squared, which is 4. And y equals 3 squared, which is 9. Notice there's a repeat in here. All right, there's a midpoint. So here's our midpoint. We have 0. And all of these values are the same for our y's. And all of these values are the same for our y's. That should happen every time you graph these. You should have this repeat effect as long as you choose the right x values. And I'm going to teach you how to choose the right x values, but right now this is a pretty standard set, -3, -2, -1, 0, 1, 2, and 3. So we're going to go ahead and graph these just to make sure we've got our parabola looking right. So -3, so 1, 2, 3, up 9, show over here. -2, 4 is right there. -1, 1, 0, 0, 1, 1. 2, 4, and then 3, 9. So what you get is this U-shaped kind of graph. Like I said before, it's called a parabola. So that's a parabola. All right, parabola. And there's some really important points on this parabola. One of them is that middle point, that changeover point. So right down the center here is what's called our axis of symmetry. So axis of symmetry. Now, if you remember from geometry class at all, symmetry means that the left and right side or top and bottom side are all the same. So that's our axis of symmetry, and that's this line right here. That's the axis of symmetry. So the right side and left side will be the same. All parabolas should have an axis of symmetry. It won't always be through x equals 0. It might be to the left, to the right, who knows. But it will change a little bit. And the other point is right here. And that is called our vertex. All right? And our vertex is the point where it changes over. So it's the x value where it changes over. So we've got that midpoint you can see is really important. X of symmetry is there and the vertex is there. So there's your first graph of a parabola. So we're going to look at some vocabulary for you just so that we can get you looking at saying the right things and how they're said. So the first one, quadratic function. It's a second degree. We talked about degrees last time. Something has to have something x squared, the second degree. A second degree function that graphs I like to put U, but I don't like to put the tail on it because then it looks bad. So a U-shaped graph. All right, so that's a quadratic function. A parabola is the U-shaped graph. This is the U-shape is what a parabola is. Now, it's not totally a U, but we kind of call it that way. There are some graphs that are V's, which are kind of cool. If you've heard of absolute value actually makes a graph that looks like that. So there's U-shape and there's V-shape. It doesn't look like W's, so it's kind of cool. Vertex. The lowest or highest point on the graph. Point on a parabola. So if the U is going up, or if it's opening up, then your U is at the bottom. So that's your lowest point. If the U is going down like that, it's your highest point. Either way, that's the vertex. All right, and axis symmetry, the imaginary line that cuts the parabola into two equal sides. All right, so those are just kind of your definitions for this. If you need to finish writing, that's fine. Pause the video, take a second, finish writing. All right, now you got those down. Let's keep moving on. Do a couple more of these. Let's graph a couple more so you can kind of look at what they look like. We have y equals 3x squared and y equals negative 1/2 x. So we're going to do two separate tables down here. We got an x and a y table for the first one. So this is going to be for my y equals 3x squared. And this one's going to be for my y equals 1/2 x squared. All right. So we're using those same values, negative 3, negative 2, negative 1, 0, 1, 2, and 3. And also over here, same thing. What I want you to do is I want you to go ahead and try and graph these on your own. See how you do. They should be able to be graphed pretty easily. And we'll get back together in just a second and see how you did. All right, so I cleaned those graphs a little bit, and I've got my points in there. I haven't drawn my lines in yet, but you can see these two graphs are very, very different from each other. I think I made a mistake in my red ones here, so sorry about that. There. And there. Okay, so my red one is kind of like this. All right, and just to let you know, I am counting by threes on the y-axis. So this is 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. All right, look at my threes and y-axis. So you can see is this, and I forgot the negatives. So I'm going to redo that in a second. This is actually going to be upside down. Sorry about that, I forgot there's a negative in front. So there's my other graph right there. These will be incorrect. All right, so looking at that again, we've got our, sorry, I forgot this negative right there. It happens, even teachers do it. All right, so 3x to 3, what that does is it makes it really, really, really tall. So that's why the numbers got so big. The 27 got so huge. The negative 1/2 makes it shallower, so it's not as tall. It doesn't get as big as fast. And the negative 1/2 flips it upside down. So we have a values, so those a's that are greater than 1 are taller. Okay, a values that are less than 1 are shallow. A's that are less than 1 are shallow. Okay, and then negatives upside down. Upside down. Good. All right. So moving on, we look at another one. Y equals x squared plus 2, and y equals x squared minus 3. So our x and y tables again for the first one, x and y for the second one. And I'm going to go through these pretty quick here. So 2, negative 1, 0, 1, 2, 3. And then negative 3 is going to be 11. Negative 2 is going to be 6. Negative 1 is going to be 3. 0 will be 2. And then it'll repeat over again. So 1 will be 3, 6, 11. On the other side, negative 3, negative 2, negative 1, 0, 2, and 3. So negative 3 is going to be 6. Negative 2 is going to be 1. Negative 1 is going to be negative 2. 0 is negative 3. 1 is going to be negative 2 again. 1 and 6. Go ahead and graph these. So negative 3, 11 is going to be up here. Negative 2, 6. So 1, 2, 3, 4, 5, 6 is there. Negative 1, 3. And then go to 2. And that repeats back over again. Alright, so there's our first one. And our next one. So negative 3, 6. 1, 2, 3, 4, 5, 6 is right there. Negative 2, 1. Negative 1, negative 2. 0, negative 3. That repeats back over. Alright, so what these have done, by adding 2, so by adding 2 at the end here, it moves up 2 spots. It shifts up. So the vertex here, at the vertex right here, has shifted up 2 spots. By subtracting 3, it's shifted down 3 spots. That's gone down 3 from the origin. So you can say plus 2 goes up 2, but minus 3 goes down 3. If you add 6, it'll go up 6. You subtract 27, it'll go down 27. All right, so that's kind of the basics of graphing parabolas. All right, we will see you on Monday. Have a great rest of your weekend. I hope everything goes well, and enjoy yourselves.